Okay, so we're going to be looking at how light reflects in a plain, flat mirror. So we have a few terms you need to learn, and you're just going to transfer them directly over to the worksheet that I attached to go with this lesson. So, again, when we're talking about rays of light, you want to make sure when you draw rays of light that you indicate direction. So in this diagram, here along the bottom is a plain flat mirror. And we're going to show a light ray hitting the mirror. So the light ray, you'll see, is in yellow. Just keep yellow, I guess. So right here. So here's the light ray hitting the mirror, and it's showing the direction in. So as long as the mirror is a flat mirror, like the one you use in your bathroom, the light ray will bounce off that mirror in a very predictable fashion. So the first thing we always have to include in our ray diagrams when we are looking at reflection off of a plane mirror is this line here called the normal. So it's a dotted line, see right down here. And that dotted line is always present. So that dotted line is always there, indicating a 90-degree angle to the mirror. Okay, and that is called the normal. And it always has to be there because we use the normal to measure. That's how we measure angles. Okay. A lot of people make the mistake of measuring the angle from the light ray down to the mirror. So from here over, and that is most certainly wrong. You never want to do that. Okay, so I'm just pointing that out. The only angles we're concerned with is the angle that the light ray makes with that imaginary perpendicular line called the normal. And that angle right is right here, and it's called the angle of incidence. Okay, and then to draw the light ray that will bounce off the mirror in that predictable fashion, you need to measure this angle right here, and the angle of reflection of that light ray will be the exact same angle. So whenever you have a plain flat mirror, the angle of incidence, the angle in which the ray of light hits the mirror, measured to the perpendicular, is always going to equal the angle of reflection, the angle that the light ray bounces off of the mirror. And, unfortunately, we can't do the labs to show you this, but as long as you're good with a protractor, you won't find this difficult at all. It's literally just bouncing that light ray directly off of the mirror. So regular reflection. So if we're looking at just a plain flat mirror, we are always, you'll notice you're always going to get this light ray in, light ray out at the exact same angle. What they're not showing you here, of course, is all the normals that are being measured. Okay, so angle of incidence equals angle of reflection. So the reflected ray bounces off the mirror at the same angle as the incident ray when it hits the mirror. Diffuse reflection is what happens when the mirror has rough portions, or the reflective surface has rough portions. And that you will get light rays coming in, and they could all be parallel, like in this case right here. All your light rays coming in are parallel, but they're all bouncing off at different directions because of just irregularities in the surface they're reflecting off of. So all surfaces have irregularities. During regular reflection, the irregularities are smaller than the wavelength of the incident ray. For diffuse reflection, irregularities are larger than the wavelength. The reflected rays are scattered. So here are our laws of reflection. Okay, and this is for plain flat mirror. The angle of incidence is equal to the angle of reflection. So again, it shows your incident ray measured to the normal and the reflected ray. The incident ray and reflected rays lie in the same plane. And this diagram shows that really nicely. Okay, so they're all lying within the same plane. You can literally take a sheet of paper and run it through both the incident ray and the reflected ray. They are in the same plane. So when we describe images, which we're going to be doing, when we look at light reflecting off of different surfaces, we use something called SALT, and that stands for S, for the size. Is it smaller, larger, the same, or the same size? The attitude. Is the image you see in that mirror upright or inverted, right side up or upside down? L, location. The image is closer, farther, or equal distance to the reflecting surface as the object. And type, real, captured on a screen, such as a pinhole camera, or virtual. And we'll go into virtual a little more later. So before we move on, we are going to figure out the size, attitude, location, and type when reflecting in a regular plain flat mirror. And since we don't have a lab to do this, I just want you to go and stand in front of your bathroom mirror right now. Okay, and we'll just go through this. So as you stand in front of your bathroom mirror, look at your size. Okay, are you the same size? Are you smaller? Are you larger? Hopefully you've come to the conclusion that, oh, look, I am the same size. So the image of you is the same size as you. Attitude. When you look in the mirror, are you upright or inverted? Okay, well, clearly you're upright, but there is something going on here. Your mirror, in a plain flat mirror, it has what we call lateral inversion. Okay, so what that means is you can tell. I want you right now to raise your right hand. When you look in the mirror, the image has the left hand raised. Okay, so that is called lateral inversion, but the attitude, you're still upright. Location. Now, look down and see how far you are from the actual mirror itself, and then look up at your image. How far is your image from the actual mirror? And what you should see is that they're an equal distance. So you, however far you are standing from that mirror, it's the same distance the image is behind the mirror. So hopefully you, got that. And the type, because it is a mirror, flat mirror, is virtual. Okay, so for a plain mirror, now you can now write what we know is to be true about reflection in just a plain mirror. The image is the same size, is upright, is the same distance behind as in front, and is virtual. Formation of a virtual image. So we're going to look at a ray diagram here. When you look at an image, your brain believes the rays are actually coming from behind the mirror. Okay, that's how your brain actually perceives that there is actual rays coming from behind the mirror. When in fact they aren't. That is impossible because there's no light coming through the mirror from behind it. So what is actually happening is when light reflects off an object, that the light hits the mirror and is reflected. How is it reflected? Well, the angle of incidence equals the angle of reflection. So at the exact same angle. And that enters your eyes. And it gives the perception that the light is coming from behind the mirror. Okay? even though obviously no light can travel there. So we call that image virtual. So what I want you to do is just on the assigned worksheet that I've attached, I want you to label the diagram and then work through the worksheet. There is some measuring of angles using a protractor. So if you haven't grabbed yourself a protractor, see if you can maybe get one, Staples, dollar store, because you're going to be needing it, that and a ruler.